I'm going to talk today about quantum computing, and this has been very much in the news lately. And the more I study this subject, the more I'm convinced that quantum computing is going to be the next big investment paradigm. And now, what do I mean by investment paradigms? These are not investments per se, but they are technological platforms that can spawn dozens of new industries, and each one of those can generate hundreds of different companies. And it's at that company level that the investment opportunities exist, and that's what I'm really looking for. Now, this next slide shows examples of what I mean by past investment paradigms. In the early to mid 1800s, steam engines brought us railroads and steamships that made the world much smaller, allowed us to travel, which was so difficult until that time. Electricity in the late 1800s changed industry and then trickled into the life of the average person. And I can't imagine living without electricity, but 150 years ago, everybody did. In the early 1900s, the internal combustion engine brought us automobiles and airplanes. In the mid-1900s, computers changed business. In the 1990s, the internet changed everything in our lives, how we shop, how we communicate, how we socialize. It was all brought to us by the internet. And in the 2010s, started the era of artificial intelligence. So as you can see on this next slide, the time span between the acceptance of these new technologies is getting shorter and shorter. So if you think that technology is advancing at a dizzying rate, you're not wrong at all. It really is. Now, artificial intelligence is the latest of these investment paradigms, and it's already been around for 10 or 15 years. And from an investment standpoint, what this means is a lot of money has already been made in artificial intelligence. And I'm not, as an investment manager and investment researcher, not interested in what made money in the past. I'm looking forward to what's coming next. And I think that's going to be quantum computing. Now, quantum computers are powerful machines that make use of the strange physics of quantum computing to solve problems that are far too complex for even today's fastest supercomputers. It always seemed that quantum computing was spoken about as being out in the future, but I'm telling you, it's right here, right now, and it's happening. Traditional binary computers are ones that treat all data as zeros and ones, or switches that are on or off. And they're designed to logically solve problems one at a time. Now, it may seem to you and I that there's a lot going on in our computer, but each processor is solving one problem at a time, doing one task at a time, just really, really fast. And that's why it seems like there's so much going on. Quantum computing is different from traditional computing because instead of using regular computer bits that are either 0 or 1, it uses special units called qubits. They can be 0 or 1 or both at the same time because of these rules of quantum physics. This allows quantum computers to try many possible answers all at once, quickly solving chaotic problems that regular computers would take years to complete. For a few nerds in the audience, these special rules of quantum mechanics are called superposition and entanglement. And this next slide gives us an example of superposition. Here's a picture of a coin that shows head, and let's say that represents the bit state 0. And the next coin shows tails, and it represents the bit state of 1. But the third coin, which can be conceived of as spinning, could be 0 or 1 simultaneously. We don't know exactly what it is. It can literally be treated as both simultaneously. So, in addition to speeds that can be millions of times faster than traditional computers, and let that sink in for a minute, what I just said, I'm talking millions of times faster than today's computers. This is a big deal, but it's not just about speed that differentiates quantum computing from traditional binary computers. It's the ability to handle the element of chance and chaos. Over the past 50 years, attempts to predict the weather using supercomputers have produced just so-so results. The problem is weather is not a single system, but a complex interaction of many systems simultaneously. So we need computers that can handle these chaotic systems like the weather, and quantum computers are just the ticket. Now, one problem that quantum computing faces is qubits are very fragile and can lose their quantum state quickly if their environment changes. Until recently, they required very cold, specialized environments, making them expensive and hard to maintain. There are currently two business models unfolding in the quantum computing arena. The first are what we call pure plays, companies that actually build quantum computers or the associated equipment. Now, these are companies such as IonQ, D-Wave, and Rigetti Computing. Rigetti builds superconducting qubit computers that operate at extremely cold temperatures required for superconductivity. Now, superconductivity is when electrical resistance drops to zero and magnetic fields disappear from around the electricity. Both are big deals for physicists and for electrical engineers. Now, I would love to get into the details of that, but we don't have time to let my geek out to play, so to speak. But if we ever get to talk one-on-one, I will be happy to get into that. IonQ, on the other hand, is focusing on a newer technology called trapped ion qubits that is reported to provide superconductivity at more normal temperatures and therefore may be less fragile. The second business model is to lease out time on computers, quantum computers that the company already owns. And this space is currently dominated by big names such as Alphabet, which is the parent company of Google, if you're not familiar with that, Amazon, IBM, and Microsoft. Quantum computing is very much still a work in progress with lots of uses being developed and lots of technological challenges we have to solve. Which technology is going to become more successful over time is hard to guess. And I have to admit, I'm not a physicist, even though I might have slept in a Holiday Inn Express one time. I hope I'm not dating myself with that old joke. Anyway, we're going to see real game-changing discoveries made using quantum computers when more and more of the research universities, corporate R&D departments, and laboratories get their own on-site machines. And this is rolling out as we're talking right now. A search on Perplexity AI tells me that only a dozen or so universities and companies have functioning quantum computers right now, but they do exist. They are happening. So we're now at the beginning of the quantum computing age, which is expected to usher in huge discoveries for mankind and huge markets for their providers. How big is that market, you might ask? I'm glad you asked. The quantum computing industry has just started making revenues, producing revenue. Last year, there was about $650 million in revenue from quantum computers. This year, it's over $1 billion. It's an outstanding 53% growth in 1 year. Now, we'd all be happy if we had 53% growth in our portfolios every year. But this is just the growth of the industry, not a specific investment. But revenues in the quantum computing market are expected to explode to $70 billion by 2030. That's just 5 years. And that means revenues are going to more than double each year going forward. This is a really big deal investment-wise. Now, in my investment research, I focus only on investable companies in the space. There are many private companies trying to become players in quantum computing, but I try not to get distracted by them because you and I cannot invest in startups. In my opinion, the companies that I've mentioned here today are the main ones to keep your eye on as this industry matures.